Hey, good morning, everybody. Hope welcome to a new week. Hope everybody had a good weekend and you were nice to your mom on Mother's Day. Just real quick, let's go through the weekly calendar so you have an idea what's going on here. Starting today, we're going to do section 11.9 with the video notes. You have an assignment due Tuesday at 11:59. A Canvas conference noon to 12:30. See, last section was a little bit harder than what we've been seeing, so I suggest you check your homework from what I've turned in and what I posted. And if you're not getting these right, you come to one of these conferences today. And then like Tuesday, we'll probably do the homework from Monday. So this will more be a review for section 11.8. And go over some of those problems. And then Tuesday, we'll probably go over the problems from Monday. Wednesday, we're going to review 11.8 and 11.9. On the video, there'll be a practice quiz for homework. Due Thursday at 11:59, and then Canvas conference from noon to 12:30. And then Friday, we do have a quiz. At this point, quiz over sections 11.8 and 11.9. Like you said, normal routine there for Friday. And this should be our last summative grade for the 9 weeks. I still got to talk with Mr. Laverick and Mr. Napholz about a couple things, make sure we're on the same page. But it appears that this will be our last quiz to this point. All righty. We're going to solve radical equations. The guided notes, hopefully you printed those off. Before we get into that, just a real quick review. Okay, real quick review of getting rid of or dividing with radicals. So if you got 3 over square root of 6, and this is not on your guided notes, so just pay attention or get this down separately. To get rid of this is just kind of reviewing. We multiply by square root of 6 over square root of 6. And then you cannot multiply outsides by insides, so that just becomes 3 square root of 6. Now here's a big thing here. Square root of 6 times square root of 6 is square root of 36. You don't need to write that. That's automatically going to be what? It's going to be 6. Square root of 36 is 6. So anytime you multiply a square root times itself, you get what's left on the inside. Double check, triple check, see whether anything will reduce or whether anything will simplify. Will your 6 in there reduce using the factor tree? And will I get any pairs? No, but the 3 and the 6 do reduce because they're both divisible by 3. And you get 1 square root of 6 over 2 because that reduces to 1/2 or square root of 6 over 2. Square root of 10 over square root of 14. Okay, I can multiply by square root of 14 over square root of 14. That gives me, those do multiply together, square root of 140. Square root of 14 times square root of 14 will just be 14. Okay, it is the square root of 196. That simplifies to 14. 140 is 14 times 10, 2 times 7, 2 times 5. So it's 2 times 2 times 5 times 7 over 14. Take out the 2 and multiply 5 and 7 back together, and you get 2 square root of 35 over 14. But we are not done. We are not done because 2 and 14 reduce, and it reduces to square root of 35 over 7 because 2 goes into 2 once and 2 goes into 14 7 times. Okay, for that. So that's the square root of 35 over 7. And let me just go through that third one here. Oh, that's all tied together. Real quick. And if you have something other than a square root, you got a 4 on the outside, just multiply by the square root of 3. Do not multiply by the 4. That gives me square root of 45. And then, all right, this is the 4. There's a 1 there. So theoretically, here's what you got. 4 times the square root of 9. But the square root of 9 is 3. 4 times 3 is 12. All right, the square root of 45, just to save us a little time, that is 9 times 5, which is 3 times 3. I got a pair of 3s. And the 3 and the 12 reduce to 1/4. So that becomes the square root of 5 over 4. Okay, for that. And so then we're done with that. All right, I want to do a little bit of review. Here's the answers to the homework. So you can go through here again. It is posted on the modules. Let me just show you there. Oh, we don't want that. And if you go to, what is it, 11/8, that second day. And then I'll remember, I always post your homework key. So you can get that. You can print that out. You can look it over as well. But as you take a look here, here is the answer key. This, you got some multiplying here as well. Don't forget, these are foiling problems for 39 and 41. And then when we get to 46 through 51, those are the ones that have the dividing here. So make sure you can go through these answers and they make sense. We'll continue to review these in today's conference. And then here's 51 as well. Okay, you got one where you got a 2 and a 3, or excuse me, a 6 divided by 3, which reduces to 2. Okay, so a lot of different problems here going on. Okay, 11/9. We're going to deal with equations. Equation has to have an equal sign. Okay, so a radical equation has an equal sign and you have a square root with a variable underneath it at some point. These are all going to be solved a little bit differently. We're going to go over them. But here's the key to solve these. To get rid of a square root, now I know this isn't on your guide notes, but this should be an equal sign. To get rid of a square root, you square both sides. Okay, and that's how we do that because of the properties that, and this is important, and we went over this before, like square root of 3 times square root of 3. That's square root of 9, but that's just 3. Square root of 5 times square root of 5 is going to be 5. So basically, if you get the square root of 5 squared, you get back 5, which means if I have the square root of x squared, I get back x. It's always going to be the case. And this is how we're going to solve these. Now, square root of x equals 5. Underneath there, put the square root of x. Once you have the square root by itself, we want to square both sides. So you get the square root of x squared equals 5 squared. That is going to be in the square root of x squared. Anytime you square a square root, you get what's on the inside. It basically undoes the square root. So that's x equals 25. There's going to be something that you really have to be careful about when you square an equation. Sometimes you get a solution that doesn't work on the original one and you have to throw it out. So you do need to check these. Most of these we can check just mentally because I can plug in 25. Square root of 25 is 5. I know that's true. But there will be one problem that we do here where we do get a solution that doesn't work. And we'll go through that here in a little bit. Second one, 10 equals square root of 2x. Okay, I got the square root isolated. I square both sides. 10 squared is 100. Square root of 2x squared is just 2x. Whatever is on the inside is what we get. Divide by 2. And I'm just going to flip the order and I get x equals 50. All right, is this true? Well, what's 2 times 50? 2 times 50 is 100. And now I take the square root of that, and that is 10. And that's what it says here. So that is correct. I know my answer is right. Square root of negative 4x equals 6. Square both sides. Now, where you don't have the square root, you do actually take 6 times 6, which is 36. Square root of negative 4x. It doesn't matter. When we take the square root and we square it, you're left with what's on the inside. Negative 4x equals 36. All I got to do is divide by negative 4. 36 divided by negative 4 is negative 9. Go back up here. Negative 4 times negative 9 is 36. What's the square root of 36? It is 6. So I know it's right. All right, so these first three are pretty straightforward. In fact, that there's not a lot of work to do. You just square both sides and then simplify. We're going to run in some equations here. We got to do a little bit more before you square both sides. Okay. As you see here, some square root equations do not have the square root isolated. You have something else on the other side. To solve these equations, you may have to isolate the square root before. Okay. This is just like getting a variable by itself. We want to get this right here by itself. That minus 4 is not under the square root. So you just do like we normally do. If I want to move a minus 4 to the other side, I add 4 to both sides. So I'm going to do that. And now that gives me the square root of x. Negative 4 plus 4 is 0. 5 plus 4 is 9. Now, square both sides. And square root of x squared is just x. 9 squared is 81. All right, to see if this is right, I take the square root of 81. This is what I'm saying. And I want to, is x. And I want to see, when I plug it back in, I get 5. Well, the square root of 81 is 9. 9 minus 4 is 5. So yes, it does work. All right, now I have more than just a 5x or an x underneath here. I got this expression 5x plus 1, but I still must isolate that before I can solve it. So I have to subtract 6 on both sides. Now that gives me the square root of 5x plus 1 equals 10 minus 6, which is 4. Now, take the square root of both sides. Not the square root, the square. When you do that, that leaves you 5x. That leaves you whatever's on the inside. Okay? Whatever's on the inside, when we take that square it, that is what we're left with. So you're left with 5x plus 1 equals, now don't forget, 4 squared is 16. Subtract 1. 5x equals 15. Divided by 5. X equals 3. All right, now do a real quick check up here. What's 5 times 3? 5 times 3 is 15. 15 plus 1 is 16. So that becomes the square root of 16 plus 6 equals 10 is what we're checking. Well, what's the square root of 16? It is 4. 10 equals 10, so we are good. All right, let's take a look at this one here. Isolate whatever is in the square root. That means I need to get rid of that plus 9. Want to get rid of that plus 9, you subtract 9. 7 minus 9 is negative 2. Negative 2 equals square root of 2x plus 3. Okay, now when you square both sides, that means you have to put that whole thing in parentheses, and that makes sure you have to put the negative in parentheses. Because negative 2 squared is 4 equals 2x plus 3. Subtract 3. 4 minus 3 is 1 equals 2x, and when I divide by 2, I get x equals 1/2. All right, let's do a quick check here. If I plug in 1/2, that's 2 times 1/2 is 1. 1 plus 3 is 4. Well, what's the square root of 4? The square root of 4 is 2, and 2 plus 9 is 11. Well, 11 does not equal 7. So that means that 1/2 does not work. We didn't do anything wrong. Okay? but it does not work, so we have to throw it out. So we say no solution. This is called an extraneous solution. Okay, it's a solution that works for the part here after we squared it, because if you would plug in 1/2 up into here, it would work, but it doesn't work in the original. It has to do because when you take the square root of a constant, that's the positive square root. And that's the positive square root for that. So it does not work. You have to throw that answer out then. Okay. So that's going to come up just every now and then. Not all the time, just every now and then. So you just got to be careful there. Now, some involve not just adding, subtracting, but multiplying or dividing. Again, we want to get the radical. We want to get the radical by itself first before I square both sides. So in order to do that, I got to get rid of this 2. Well, this is no different than 2x equals 22. You divide both sides by 2. Okay, we're going to divide both sides by 2, but it gives me the square root of x equals 11. Okay, now I take square root of x squared equals 11 squared. That gives me x equals, and 11 squared is 121. Okay, now that was just an example. That wasn't telling you the final answer is 11. So 121, if you do check that one, square root of 121 is 11. 2 times 11 is 22. So that does show that it is correct. So we are good there. All right, now this one's a little bit more involved. 2 square root of x over 5 equals 4. I would probably tell you to do this in 2 steps. Now, if you notice, I kind of got this moved over to the side a little bit. I'm going to get rid of the 5 first. Since you are dividing by 5, remember, to get rid of something that's being divided, you multiply. So I'm going to multiply this side, and I'm going to multiply this side. And when I do that, what happens is those 5s cancel, and you're left with 2 square root of x. I do need to multiply 4 times 5 together to get 20. Now divide by 2, and I get square root of x equals 10. Not done, though, because now we square both sides, and I get x equals 100. So then I'm going to check it just to see if I'm right. I got 2 square root of x divided by 5, and I'm telling you that equals 4. We'll plug in 100 here. Well, square root of 100 is 10. 2 times 10 is 20, and 20 divided by 5 is 4. So it is right. Okay, so it is right. So in this case here, again, we have to get to whatever the radical is by itself. We had to do a little bit of dividing first. In this case here, I had to multiply by the 5 to get rid of the 5 and divide by 2. Oh, excuse me, I'm yawning. All right, the last type is when we have more than one radical. And what we want to do is we want to get the radical on both sides. We would, like this one is written. This is how we want it. Once you get that, now you square both sides. And when you do square both sides, that just leaves you what's on the inside. But I got to do a little bit of work here. This is just a good old-fashioned equation. Get x by itself, so subtract x. I get 2x plus 2 equals 6. Subtract 2. And I get 2x equals 4 divided by 2. X equals 2. Got to check it. What's 3 times 2? 3 times 2 is 6. 6 plus 2 is 8. So on that left-hand side, I get square root of 8. And then what's 2 plus 6? Well, that's 8 as well. That's all I need. Square root of 8 equals square root of 8. I know that's true. They're equivalent, so that means x equals 2 is correct. So that's my answer. So now we got 2 terms with radicals in them. All right, if you look at B there, I got two terms of radicals. Before you square anything, you want one radical on the left of the equal sign. You want one radical on the right of the equal sign. I don't want them both on the same side because when you square that, it's not just dropping the radicals. You'll get it incorrect. You want to move this over. And that gives me square root 2x minus 5 equals square root of 6. Now, go ahead and square both sides. And that gives you 2x minus 5 equals 36. Add 5. And I get 2x equals 36 plus 5, which is 41. Divided by 2. It works out to be what? Oops, hold on. I made a mistake. When you square the square root of 6, this is my mistake. That's square root of 6 times square root of 6. It's the square root of 36, which is just 6. That should be a 6. Okay. And then 6 plus 5 is 11. And 11 divided by 2 is 5.5. Okay, and now when I check it, 2 times 5.5, well, it just means you double it, which is 11. And 11 minus 5 is square root of 6. So I left with square root of 6 minus square root of 6 equals 0, and that's true. Okay, all right, so fix that little mistake I had there. Square root of 6 squared is just 6. All right, for that. Now, we only had one case where the answer didn't work. One, what we call extraneous solution. Everything else, the answers did work. So it's just going to be every now and then that happens. Okay. All right, here's your homework, 3 through 31 odd. I do not think any of those are extraneous solutions. Okay, I do not think so. All right, for that one. And like I said, this one will probably more touch on Tuesday in the Canvas conference, go through most of the homework here to tune in. Monday or today, we're going to go through section 11A because there's some issues there. Some people need to get worked through. All right, you guys have a great day. I will talk to you later.